Welcome to my channel, dear student. This is a two problem of a vector. And these two theorem we have to solve by the vector method. It is given that the two question here is ABCD is a parallelogram and P and Q are the midpoint on the sides AB and CD respectively. Then show that BP and BQ trisected AC and trisected by AC. And the second question is that ABCD is a parallelogram and A is the midpoint on a midpoint of CD and AB is a point on AE such that AF is equal to 2/3 of AE, and so that the F lies on the diagonal BD and FB is equal to 2/3 of BD. Okay. See, for the first problem, a drawing need to draw here. See, this is a parallelogram, that is ABCD. This is here A, B and C, D. Let us assume O as the origin. So join the two diagonal. Okay. Join the diagonal AC. And P and Q are the midpoint of AB. And Q is the midpoint of CD. Okay. This is here P and this is here Q. Okay. Midpoint on the side AB and CD respective. Then so that PD, this is PD and this is BQ. Okay, and this is BQ, trisected AC. Okay, so now let us assume it is trisected as C. So let the position vector now, now this is here R. Now let the position vector of taking A as the origin, A as origin, let the position vectors of B and D, position vector of B and D are small b and small d, okay, respectively. Since A, B, C, D is a parallelogram, okay, therefore vector BC, this is B to C, and this is equal to vector that is same sense and same direction. So that is BC equal to AD, that is D here. So it is given the position vector of D, this is D. Okay, this is D with respect to origin. So you can say this is the D vector along AD, and same as BC are equal vector. Okay, same sense and same direction. Okay, and same as the position vector, now we have to find the position vector of C. And here is position vector of B. This is B. Okay, this is B. Same as D. Actually, this is DQ. So it can be written as AV is equal to DC, and that is equal to B here, and AD is equal to BC, that is equal to D, and the position vector of P, this is P and this is Q. So therefore the position vector, therefore the position vector of P is, that is half of AB, and this is the vector is B here, so this is B by 2. Okay, and the position vector of Q is actually this is parallel to okay, this is also B by 2. Okay, now we have to find the position vector of C. Now we have to find the position vector of C. Now for triangle ACD, it can be written as AC plus CD plus DA equal to 0. So AC is equal to, it means the position vector of C, it can be written as DC minus DA. Okay, DC minus DA. And now see DC, this is D to C, the position vector of this DC, that is actually B here. Okay, and now DA and DA, so it can be written as a AD. So vector B plus AD, that is D. So therefore the position vector of C is B plus D. S is trisected. S is a point which is trisected which trisect AC, which is trisect AC, then the position vector of S, that is AS, so this is 1:2, so that is equal to 1 into C, that is AC, plus 2 into 0, actually the position vector of A is 0, null vector, this is 2 plus 1, and AC means the position vector of C, so that is B plus D by 3. Okay, again, if S just be the point which divide PD in the ratio two is to 1. So it is just be the, let us assume this is not a same point, this is another point, this is S dash. So let us assume these A's and S dash are not same point. Okay, so now that's why if we let us assume S dash be the point on which divides PD in the ratio 2 is to 1. This is at 2 is to 1. Okay, then A is dashed, and that is equal to 2 times of 2 times of OP, that is the position vector of AP plus 1 times of AD by this is 2 plus 1. Now the position vector of AP is B by 2. So this is position vector of P, that is AP, that is B by 2. And the position vector of D here is AD, that is D by 2 plus 1. This is B plus and D by 3. See, these two vectors are same. So as the position vector of S and the position vector of S dash are same, so S and S dash are same coordinate. So that is equal to the vector, and that is AS. Okay. So then AS equal to this. Okay. So therefore, showing that S and S dash must coincide. Thus, PD cuts diagonal AC at its point of intersection. Point of intersection is which is also trisected, which is also the point of trisection of PD. Similarly, we can prove that BQ. Similarly, we can prove that BQ is trisected by R, and also R is trisected AC. Okay, so it is proved. For the second question, see, ACD is a parallelogram and A is the midpoint of CD, and F is a point on A such that AF is equal to 2/3 of A, so that F lies on the diagonal BD, and BF is equal to 2/3 of BD. Okay, so first draw the diagram here, and same question as like first. So see, this is a parallelogram, that is A, B, C and D, and here E is the midpoint of CD. E is the midpoint of CD. Now draw AE. F is E is the midpoint of CD, and F is a point on AE. F is a point on AE such that it is trisected at that point to the diagonal at F. Okay. Let A is the null point, origin. Okay, is origin. Now Therefore, the position vector of B, let us assume as a B. Position vector of D as a D. So, AB is equal to actually DC. This is a parallelogram, so it has the same sense and same direction. So it can be written as the equal vector. As the position vector of B here is B, so that is the vector AB, same as DC. So this is here B vector. Okay, and same as the position vector of D is here AD, and this is also same sense. So this is BC. So no, this is BC. So the vector here is D. So okay, so this is D. Now AE, AF is equal to 2/3 of AE. Okay, in length. Now this is FE is equal to AE minus AF. So AE minus 2/3 of AE. So this is equal to 1/3 of AE. So it shows that AF is to FE, that is 2/3 AE is to 1/3 AE. This is 2 is to 1. Okay. Therefore, the position vector of AF. So this is the position vector of AF. So that is actually, okay, this is the position vector of AF. So this is divide 2 is to 1 ratio. So 2 times of AE plus 1 times of OA means 0 vector actually, and that is 2 plus 1. So 2 times of this is 2/3 of AE vector. Okay. Now AE is equal to, for the triangle AED, for triangle AED, so AE plus ED plus DA is equal to 0. So need to find AE here. So that is DE and AD. And here DE. This is here D by 2. So this is the position vector of okay, and AD is D. This is 1/3 of AE is equal to half of B plus and 2D, 1/3 of B plus 2D. Okay. Now BD is equal to AD minus AB. This is AD. AD vector is D here, and this is AB. This is B. Okay. Now for triangle, now need to find here. Let us assume this is F or not F dash be the defined point. Now you have to show F and F dash as both same. So now we have to find DF, okay, and BF dash. Okay, this is here f dash and this is here f. Now find the position vector with respect to the triangle and this for triangle B F B F A. So that is BF plus FA plus AB equal to 0. So BF is equal to F plus BA. Okay. So now AF. This is AF, the position vector of F. F is equal to 1/3 of B plus 2D. And BA that is minus B plus 2D minus 3B. This is 1/3 of 2D minus 2B. Okay, take common 2/3. So okay, 2/3 of D minus B for BF. And for triangle AFD. Okay, so FD plus DA, FD plus DA plus AF equal to 0. So FD is equal to AD minus AF. AD vector, this is D. AF vector, this is AF. AF is here 1/3 of B plus 2D. Take LCM, this is 1/3, 3D minus B minus 2D. This is here 1/3 of D minus B. Okay, if we add these two vector, so see, now we have to find BF and FD. So BF plus FD, that is equal to BF means this is here 2/3 D minus B, 1/3 D minus B. This is here actually D minus B. So that is equal to now this is BF and FD. Now find BD. This is AD minus AB. This is AD minus, so here BD. This is D minus B vector. So that is equal to BD. So it's proved that the sum of these two vector is equal to BD. So it means F lie on the F dash. So F and F dash are same point. Okay, that is the proved. Therefore, we can say from this statement, from this decision, so F and F dash are same point. The point Point F on AE also lies on the diagonal BD. Proved. Thank you for watching my video.